Yes, I am Babu. Very good evening to everybody. Today we are going to start the name of the lesson is gravitation. And from this gravitation, before going to speak about the gravitation, this is a simple concept. This is a pen. It's a marker. If I hold the marker for a short period, I won't get the pain. If I hold it for a long time, what will happen to this? I'll get the pain here, and then I'm going to get a much pain if I hold the pen for a long time. Even though in the life also, if you are going to hold a problem, if that means if you are going to speak or if you are going to think about a problem for a long time, it is also it is also a big problem that makes me suffer like anything in the life. So, if you are not thinking about the problem, it is very light. If you are taken as very light, you don't have any problem in the life. From this, we can assume, we can learn the physics. Why, if I leave this pen, it is falling down. May I know why this pen falling down? The pen falls down because of the name of the gravitation. So the gravity, whenever a body is associated with amount of mass, it is experiences the gravitational force. Supposed to be, if you are going to talk about the gravitational force, the characteristics of the gravitational force are they are always attractive forces. In a sense, supposed to be, if I release this body, it is falling down. What is the reason behind why not it is going to be upward direction, why it is falling down? Because there is one kind of force which is pulling the objects towards the earth. No object can move away until we apply the external force. Simply if we are dropping that one, it is falling down because of some force is acting on the body in downward direction. The name of that force is called the gravitational force. Next thing, so this kind independent of the medium between the particles. What is the conclusion of this? Supposed to be there is two objects are there. Let us consider the first object of mass is m1. Second object of mass is m2. Beginning this space between these two is occupied by the air. Now this time I fill this gap with some other liquids. Even though you fill with the liquid between this gap, but there is no change in attractive forces. That means the force experienced by the one body due to the second body never change. That means the medium between the two masses is independent of the medium between the objects. The same case is asked with neat. Let us consider the two masses m1 and m2. Those two are separated by a distance of d. Now the force between these two masses is F. If you apply it, suppose to a castor oil, then some other you introduced, what is the new force he asked in need. So if I am going to speak about the gravitational force between the two objects is independent of the media. So that is why even whether it is a castor oil or some objects or something else, if you are introducing between these two, there is no change in the force experienced by each other due to themselves. That means the medium between the masses is not affecting the forces between them. The next point is F versus R square is a rectangular parabola. What is the meaning of rectangular parabola? If you are going to F versus R square is a rectangular parabola. If you plot the graph F versus R square, the graph look like this is. So now this is called a rectangular parabola. So if you are introducing any media between these two, it won't change according to this one. Even if you are introducing the media M1 and M2, there is no changes takes place in the force between the masses. While coming to the next one, that is nothing but the force versus distance. If you are going to plot the graph force versus distance square, it is a rectangular parabola. It is shown as shown in figure. Here along the y-axis we are assuming the force. Along the x-axis we are assuming square of the distance. If you are plotting the graph between these two, the graph is look like a rectangular parabola. Now we are going to discuss another characteristics of the gravitational force. The another characteristics of the gravitational force is it forms the action and reaction pair. Let us consider two masses m1 and m2 are the two masses. One is m1, other one is m2 are separated by distance of d. Due to one body, the other is experiencing F12 and as well as the other body is also experiencing F21. But these two forces are equal and opposite in direction. F12 is equal to minus of F21. That means one constitutes the action, other is constitutes the reaction. The total sum of the force acting upon the system is equal to 0. Action and reaction are the two forces which are experienced by the two masses. That's why the total force experienced by the system is equal to 0. If no force is experienced, body is continuous state of rest or moving with uniform velocity. This is the basic condition of the gravitation. If you are going to talk about the gravitational forces, the masses must be at the static condition. It satisfies that condition. While coming to the next point, that is, it is a central force. The force exhibits no longer angular dependency. Angular dependency in the sense, supposed to be, let us consider a body of mass is m1 at the center, another body of mass is m2 at a distance of d from the m1 mass. Now you are moving the body from this position to this position by making an certain angle. Whether you are the bodies here or here, the force between these two remains the same. That means whether it is 90 degree, 180 degree or 60 degree or even 0 degree. Also there is no changes in the forces between m1 and m2. That means the force between m1 and m2, it is dependent or independent of the angle? It is independent of the angle. That means gravitational forces are the central force, means that it is a no angular dependency force. Like the central force is that force which directed towards or away from a fixed point. That means you can understand very easy way, that is, their experiences action and reaction like centripetal and centrifugal forces. Centripetal and centrifugal forces, one is acting towards to the center, other one is acting away from the center. Finally, they are making the body in the same position without any changes unless you apply the external force. This is the concept of central forces. It is very useful in solving the problems. I will explain one problem how to solve these things. Let us consider three masses m1, m2 and m3. The three masses are identical masses are placed in the corners of equilateral triangle ABC. Now the distance between the side of this equilateral triangle is A. The angle between any two corners is equal to 60 degrees, and the force, you are going to calculate the force between any two masses and we are going to calculate the force experienced by any one of the mass. In such a case, let us consider masses are the same, distances are the same. Even though the mass forces is also same, that F1 is equal to F2, that is equal to G m1 m2 by r square, that is the F. Now m1 is equal to m2 is equal to m3 and r is equal to a, f1 is equal to ft is equal to g m square by a squared. According to parallelogram law of vectors, if p is equal to q, r is equal to 2p cos theta by 2. That means 2f cos 60 divided by 2 cos 30 that is equal to root 3 by 2. 2 is cancelled F root 3. Then resultant force is equal to F dash gm square by a square into root 3 newtons. This is the resultant force experienced by any one of the mass due to the remaining masses. So this is the one. It is also based on the concept of central forces. Then here you have to understand that whether this one experiences for this direction or this direction, it is along the line joining the centers. There is no angular dependency, it is independent of the angular dependency. Not only in this case, one more problem I can explain with the help of the central forces when the gravitational force is supposed to be exist between these two. This time we are going to speak about the square. Let us consider a square of sine scale, 4 identical masses kept at the corners of the square, that is A, B, C, D. All these masses are the same, that means M are the 4 forces. Now, if I am going to speak about this thing, we want to calculate the force experienced by any one of the mass due to remaining masses. That means one experiences due to 1, 2, 3 forces we need to. That means how many forces it is going to be experiences? 3 forces it is. Due to B, F1, due to D, F2, due to C, F4 are the 4 forces. Where F3 is the resultant of F1 and F2. Now come to the point. Here masses are the same, distances are the same. That is why F1 is equal to F2 is equal to G M1 M2 by A square, where G M square by A square. Coming to the point that F2 and F1 both are perpendicular to each other, then from the parallelogram law of vectors, F3 is equal to root of F1 square plus F2 square, that is equal to root 2 into F1, where F1 is equal to Gm square by A square. Now F is the resultant force of the F3 and F4, and F3 and F4 both are parallel to each other. If theta is equal to 0 degrees, R is equal to P plus Q. That is F is equal to F3 plus F4. I substitute the F3 value, that is F3 value is equal to what? The value of F3 is nothing but the value of F3 is nothing but root 2 Gm square by A square plus Gm square by 2A square. Gm square by A square is common, then you are going to get 2 root 2 plus 1 divided by 2 is equal to F. So this is the resultant force experienced by the mass which is kept at the A due to remaining masses, that is B, C, D masses which is placed at the corners of the square of side is A. This is the force. F is equal to Gm square by A square 2 root 2 plus 1 divided by 2.